Alright, well, it was a good run of 8 days, but apparently today is probably going to be a streak breaker. Hard, find sum of array product of magical sequences. You're given two integers m and k, and integer array nums. Sequence is called magical if it has size m and 0 is less than or equal to the value at the sequence at I less than nums.length. Less than nums.length. Okay, so each value in the array is an index as well into that array, maybe. The binary representation of 2 to the power sequence of 0 plus 2 to the power sequence of 1 plus dot 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 2 to the power of sequence of m minus 1 has k set bits. Oh my god. The array product of the sequence is defined as product of the sequence equals nums of sequence of 0 times nums at sequence. So nums at the sequence, so the sequence is indices, where if I do the product of the values at those indices in the array, that equals the product of the sequence, or the defined function product. Return the sum of the array products for all valid magical sequences. The sum of the array products for all valid magical sequences. Okay, I probably need an example here. A set bit refers to the bit in the binary representation of the number that has a value of 1. Refers to a bit. Has k set bits. So it's the number ones in the binary representation of the number. Okay. So here nums is a 5-value array of basically powers of 10 from 1 to 100. No, 1, 10 is missing 1,000 and 100,000. This looks like a million. Okay. Output is that random thing. So all permutations of 0, 1, 2, 3, 4 magical sequences, each with an array product of 10 to the 13th. Oh my god, what is going on? Sequence is magical. So the sequence has size m, so each sequence has to have five things in it. The binary representation of 2 to the power of sequence. Okay, so 2 to the power of 1 plus 2 to the power of 10, 100 has k set bits into it. Has k set bits. The array product of the sequence is defined as product of the sequence equals nums. Wow, this explanation is It is a nominal explanation in the sense that it stays as an explanation. But is that really explaining? Each with an array product of 10 to the 13th. What is going on? Okay, example 2, m is 2, so sequences are 2 values. sequences are two values. So magical sequences are 0, 1. Return the sum of the right. So 0, 1. So we're talking about those being the indices of nums. So 5, 4. And then k is 2 is what? It has k set bits. So if I did 5 times 4, that's 20. 20 in binary form is product of the sequence. The array product of the sequence. So, okay, 5, 4, 2 to the power sequence of 0. Okay, so 2 to the power 5 plus 2 to the power 4. Okay, so that's like, in binary, that's like 1 and 4 zeros, I want to say, plus 1 and 3 zeros to the first, second, third form. So that's 1, 1, 0, 0, 0. So that's how k is equal to 2. And so you would take 5 times 4. Sequence of 0. I'm doing something wrong here. Nums at sequence of 0 is 5, and nums at sequence of 1 is 4. So the sequence is like 0, 1. And then nums at those sequence is like 5 and 4. So 0, 1 is what we're dealing with here. Yeah, okay. But the array product that we're adding is 5 times 4, so sum of array products would 20, and then whatever the next one is. 0, 2. 0, 2 would mean that this is 2 to the 0 plus 2 to the second, which is 1 plus 4, which is 5, which has 2 binary, 2 set bits. And then if you have 0, 2, then you're dealing with 5 and 3. So 5 times 3 is 15. And then you do this for all the other stuff. Good board. And it adds up to 170. Okay. Alright, so this thing is k is at most 30, m is at most 30, sequence can be at most 30 long. Okay, so in theory, if you do 2 to a certain power, that by itself should only be 1 bit that's on. That by itself should only be 1 bit that's on. If it's duplicated, then it becomes 1 bit in the next power. So if you deal with like 1, 0 plus 1, 0, that's binary. That becomes 1, 0, 0. So if there's a duplication, then it cancels, kind of. Cancels one of them and makes it into something that is 1 bit higher in value, place value. Okay. Two, 5, 4. So these are those are kind of independent of the actual nums, in the sense that nums is like, it could be any kind of arbitrary thing, and it's, if I'm given m equals 2 and k equals 2, then the actual sequences are kind of predetermined. So nums, the values of nums doesn't actually affect how many magical sequences there are. So I am guessing this is, I mean, maybe it does affect it, because it's going to be, it needs to be, for 2, it needs to be, you choose 2 of the possible indices. So it's the number, just the length of nums, choose 2. Because the length of nums here is 5, and it's 5, choose 2. No, sorry. Order matters. Oh wow. Order matters. So it's not choosing, it's permuting. 5 times 4, so it's 20. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's 20. I guess you can't ever have 2 to the same power. So it's not gonna actually, yeah, okay. So that makes it a lot easier. So it's the length of the nums choose k is gonna give you the, it's gonna give you the indices. So here it's like 5 choose 1. No, sorry, it's 5 choose 5. Yeah, you need all the indices in order to have, yep, 5 choose 5 there. So the only sequence is 0, 1, 2, 3, 5, or 0, 1, 2, 3, 4. It's 1 choose 1. Okay, so since each sequence value gives, no, sorry, it's not 5 choose 5. It's permutations. It's 5 permute 2, 5 permute 5, and 1 permute 1. Since each sequence value gives a bit, the length of the sequence is k. Order matters. Yeah, order matters in the sequence. So it's permutations rather than combinations. So sequences, the number sequences So sequences are permutations of MPK, where M is the length of nums array. Is this possible? Place value bits, and K is the number that are turned on. Basically ones instead of zeros. Okay. MPK. Okay. So you're, no, actually, that's NPK. And M is already used for, what is M used for actually? M is the length of size of the sequence. I'm kind of getting confused here. M is 5. They're using nums that have the same, okay, so this thing is 5, choose 2. We're using M and K being the same. It's tripping me up here. Using M and K be the same. What is the difference between M and K? It should be N. So N choose K, N or NPK, N permute K, or is N permute M? So if the length of your sequence is longer than the number of, is bigger than the number of K, I'm pretty sure that K can't be bigger than M. M can be bigger than K. Yeah, okay. Because what happens would be if each value in the sequence is unique. Okay, so each value in the sequence is unique, then K and sequence has length M, then number of set bits will be M. So if there's like, the sequence is 0, 3, 2, so it's like unique. So that means that each of those turns on a bit, so it'd be 3, or 0, 3, 2 being 3 values that are unique. But if there are duplicates in the sequence, then number of set bits will be less. So if the sequence is like 0, 0, 1, then what you're doing is you're adding 1, 1, and 1, 0 binary. Or actually, let's say 0, 0, 2. So the binary version of that would be 1 plus 1 plus 1, 0, 0, which equals 1, 1, 0, which is 2 set bits rather than 3, which is M. And then in the extreme case, if you have something like sequence 1, 1 or 0, 0, 1, then what you're doing is you're adding 1 plus 1 plus 1, 0, which just gives you 1, 0, 0, which is 1 set bit. Because the 1 and 1 combines to 2, and then 2 plus 2 combines to 4. Binary 4 is 1, 0, 0. Okay. So I guess here if they ever give me something where k is bigger than m, then I can return impossible case. If k is greater than m, turn 0. So the simple case would be just solving for m equals k, and then working from there, I guess. So each value is unique. Each value in sequence is unique. K equals, or let's say k not equal to m, turn -1 for the time being. Okay. So if k equals m, then I'm going to do the permutations. Every possible permutation of n choose k or n choose m, which is identical. So n could be up to 50. So this could be 50 choose or 50 permute 30. That's a lot. Maybe permute 30. If I can generate those permutations, and then once I have it, actually, can I? Oh my god. NPR 5030. Oh my god. What? Okay. There's just no way. It's 10 to the 46 possibilities. 50 permute 30. Huh. Okay, so there's something I'm missing that's pretty big. All permutations of 0, 1, 2, 3, 4. 5 permute 5. I must be doing this backwards or something. 5, all permutations of 0, 1, 2, 3, 4. 5 permute 5 is, that's not 1, is it? It's the same thing as 5 factorial. 120. 50 permute 30. 50 permute 30. NPR is n factorial over n minus r factorial. So the biggest it could be would be 50 times 49 times 48 all the way down to like 31, all the way down to 20. 50 minus 30 is the denominator, so that's 20. So all the way down to 21. 50 times 49 times 48 all the way down to 21. Oh boy. The array product of sequence is defined as product nums at sequence of 0 times nums at sequence of 1. Okay, let's consider the implications of that. So if I have something where I'm doing 0, 1, which is 5 times 4, and 1, 0, which is 4 times 5. Guess even though they're different sequences, they're the same product. They both can be 20. Okay. Products don't matter. Or a sequence will have the same product as another sequence with the same, like a permutation, a sequence permutation will have the same product value as another sequence permutation. Yeah, because nums at 0 times nums at 1 is the same thing as the nums at 1 times nums at 0. So it's the combination that matters. Or a permutation that falls within the same combination of numbers, assuming they're all unique, is going to give the same product. So all the permutations of 0, 1, 2, 3, 4 are all 120 of those would give the same multiplication. Okay, so what is that multiplication? So like if I have nums at 1 times 10 times 100 times, what is the product? Product equals 1 for every value in nums. I'm just working with the first example. Product equals times equals this value. And because there's 120 versions of this, the answer should be 100. Answer times 120 mod this, whatever this thing, mod 10 to the 9 plus 7. Okay, let's see if this works. I think it probably does. What? Return product. Okay, so that works for the first one. So for the second one, you're dealing with, what are you dealing with? Every combination product is going to be duplicated because there's going to be two sequences with that combination. 0, 2, 2, 0. So it'd be 10 choose 2 combinations. So 50 choose 30. That's still too much. Oh my god. This is the simpler case as well. Fifty choose 30. So I mean, at least right now all the combinations are have the same frequency. So therefore, if I do any two combinations, if I do the sum of all combinations that are 2 in length, multiply that by 2, take the mod of that, that probably works. So all combinations that are 2 length. And then the question is, can I quickly compute that? All combinations that are 2 length. How to quickly calculate all products from 2 length combinations. Products of 2 values from nums. Calculate the sum so this is example 2. So you have, so I need to pick any two. I need to pick any 2 values here. 5 times 4, 5 times 3, 5 times 2, 5 times 1. Hmm. 5 times 4 plus 5 times 3 plus 5 times 2 plus 5 times 1 plus 5 times 0 plus 4 times 3 to 1 plus 2 times 1. I mean, 5, I can factor that and say 5 times the sum of all values after it, 4 times the sum of all values after it. So it's like 5 times 10 plus 4 times 6 plus 3 times 3 plus 2 times 1. That's 50, 24, 9, 2, 74, 83, no, 74, 83, 85. 85 times 2 is 170. So that, I could do that in one pass. If I do like a prefix or suffix array, suffix sum array. Or I can do the reverse and do like 4 times the sum of the things before it, 3 times the sum of the things before it, 2 times the thing. So then I would use a prefix array for that. Then, okay, so can be done with kind of a suffix sum array, like array at k times the suffix at k for all k in length of array. Alternatively, I can do array at k times prefix array at k for all k in length of array, in range of length of array. Okay, so generalize. So if m is k equals 3, instead, how to quickly calculate the sum of all products of 3 values. So say nums is the same, 5, 4, 3, 2, 1. So what would it be? Oh my god. 5, 4, 3, 2, 1. Nums. So 5, 4, 3. So so like 5, 4, 3, 5, 4, 2, 5, 4, 1, and then 4, 3, 2, 4, 3, 1, and then 3, 2, 1. So there's 6 combinations. There's 6 combinations. So it's like 5. It's like 5 times the sum of all combinations starting at the next index that's too long, or yeah, so it's like I think I've seen this before. It's n. So let's say how to express this. The sum starting at a certain index and with a certain amount certain k digits, I guess. Start index is equal to the array, and let's call this the function of sk. Is going to be the array at s times function of like s plus 1 k minus 1. So you move down the chain, so that would give you like 4 3 4 2 4 1, or oh yeah, I screwed up here. 5 4 3 5 4 2 5 4 1 5 3 2 5 3 1 5 2 1. Yeah, so 4 3 4 2 4 1 3 2 3 1 2 1 is the stuff that could be is the sum of the products for the function s plus 1k minus 1. Let's move down one digit, decrease the number of things in your sequence. So 5 times that, or plus f of s plus 1k. Move down, you skip this digit basically, or you skip this value in your array. So then you start with 4, and then you choose 3 from there. Oh my god. Well, I think that's the right answer. So let's see, 543 is 120, 542 is 60, 54, no, 543 is 60. 543 is 60, 542 is 20, 40, 20, 30, 10, no, sorry, 20, 24, 12, 6. So this is 100, 20, 30 is 150, and then 24, 6 is 30, plus 20 is 50, plus 12 is 60, plus 2. So it's like 2, 1, 2. Each of these is 3 values that can be rearranged, so times 6. So therefore it's going to be 1272. Okay. Test case. Say it's 3, 3. Hopefully this is correct. Oh, shucks. Did I miss something? So my number is less than what it should be. Not off by much. 1350. 225. So I'm missing like 13. Missing 13 is unusual number to miss by. Unless I just added wrong. So 5, 4, 3, 20 times 3, 20 times 2, 20 times 1. 5 times 3 is 15 times 2 times 1. 5 times 5, 3, 2, 5. Wait, what? 5, 3, oh my god. 15, 10, 4, 3. Okay, so that reduces by, I don't know. Let's calculate again. That's just making it strictly smaller though. 60 plus 40 is 100. 35, 10, 24 and 6 is 30. 100, 40, 47. That's 187. Oh my god. What's 187 times 6? That's not even. Okay, I'm missing something big. 4, 3, 2, 4, 3, 1. 4, 3, 2, 4, 3, 1. Oh my god, I'm missing the 4, 2, 1. That only gives me 8. 5, 4, 3, 5, 2, 2, 5, 4, 1. 5, 3, 2, 5, 3, 1, 5, 2, 1. I think that's right. So 5 and then 4 choose, and then from the remaining 4 choose 2 of them. So 4 choose 2 should give me 4 choose 2 should give me more than this, no? 4 times 3 is 4 choose 2. 4 times that should give me 6. 1, 2, 3, 4, 5, 6. And then well, it's supposed to be 5 choose 3. 5 choose 3 should be 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. Oh boy. Yeah, I'm pretty off. Either that or I'm miscalculating some of these multiplications. 5, 4. Okay, so 1, 2, 3, 4, 5. Why is there only 9 summations here? Fuck me. Okay. 60, 40, 20, 10, 30, 15. Oh my god, I deleted a 30. 24, 12, 8, 6, 100, 50, 24, and 6, 12 is 30, 8 and 12 is 20, and then 15 and 10 is 20. So that's 100, that's 225. Okay, finally. Oh my god. Okay, the basic thing is there, even if I can't do the fucking math. Okay, so I think I can probably do that case. Okay, so it's going to be don't need to calculate that. K not equal to m. This is temporary stopgap for not handling more difficult. M is greater than k, or m is greater than k case. Okay, so I think I just need to make a subfunction here, or helper function. So let's say get combination sum for start index and k, or let's say k is not used here. Say it's p, I guess r, yeah, r, and that's simply going to be I guess I need to do a base case. This is recursive. If the start index is equal to the length of the nums, which is n, then that's not possible. So if the start index is 5, yeah, return 0. This is base case, or base cases probably. Or if you're choosing zero values, then I don't think it's possible. Otherwise, everything else is possible. So you just return the nums at the start index times recursive start plus 1 and r minus 1, or move it down. Okay, so get combination sum start plus 1 r. I guess also it's not possible if you choose, if there's like not enough values remaining. Maybe I should do that as a base case as well. Not enough values remaining, or the number of values remaining is, I think, n minus s, n minus start nums. Yeah, if that is less than r. So if there's only one value remaining, you try to take 2 values for your combination. Wow, why is start equal 5? That's not it. Start equals n. Base case, no recursion, no recurse if end index. Zero values to be used, or trying for more or getting more values than left. Okay, so I think that's the combination sum, and then you need to multiply the combination sum by the number of permutations that it can do. So I think that's just the factorial of r. Okay, so is there a factorial function? I think there is. I think it's just factorial. Okay. So I think this is just going to be return get combination sum for start being 0, r being m or k, doesn't matter. Is it called factorial? Math.factorial. Okay. Oh boy. Did I return? Well, one thing I need to do is make this mod. But this thing not returning anything is a little concerning. So it's always returning 0 from this thing. Or it's either that or factorial of m is getting me 0. K greater than m. Okay, let me double check here. Print call start r return value. Okay, so it's returning 0 a bunch of times. I guess it's always multiplying by the value. Multiplying by the value of, okay. So what is going on here? 5 times 4 plus 5 times the sum of 4 times 3 plus 4 times 2. But it can be 0. Why would it be always 0? Start is 0. So when it got to 4, 1, so start index is 4, 0, 1, 2, 3, 4. Okay. Okay, the base case is wrong. I think the base case should be if r equals 1, somehow needs to return the value. Value times the sum of these things. So if is the base case actually 1? Is the base case 1? I don't. Maybe it is 1. get combination sum. Oh my god. This cannot possibly. 5 times 4. Okay, so if this array was just something like this array was 3 length, then I'm choosing 3. Start still 0, choosing 3. So say my nums is 3, 2, 1. So the only summation should be 3 times 2 times 1, which is 6. So that should be 3 times function starting at index 1, choosing 2, plus function starting index 2, choose 3. This clearly should be 0. And somehow this should be 2. So this should be f of, this should be, this is f of 0, comma, choose 3. And then f of 1, comma, choose 1, starting index 1, choose 2. So 2 times f of start index 2, choose 1, plus, this should be impossible. So this should just be 0 here. Can't choose 3 from 2 elements. So maybe this case should return 0. I'm not sure. So and then this should be f of starting index 3, choose 2. F of 2, choose 1. So this should be 1 times f of 3, index 3, choose 0, plus f of index 3, choose 1. This should be impossible. It should be 0. But then this should also return 1. Okay, I think maybe if I choose 0, it should be returning 1. There's one way to do that. And then the other case is, this should in theory return 1. 3, choose 0. Or no, otherwise this should return 0. If you're at the end, maybe. Oh god. It's the weirdest bugs. I don't fully understand the logic. Okay, so it looks as if the case where m equals k is being solved. Oh, m is less. Okay, this is the impossible case that I was considering. Yeah, it's not possible to actually have m is bigger or k is bigger than m based on that constraint. Okay, so the question is the more difficult case. More difficult case being somehow your bits are combining. So the case where's that? This case. But you can't have duplicates in your sequence, can you? Can you have duplicates in your sequence? Sequence. I'm pretty sure you can't have duplicates here. Yeah. Like, let's do a test case here. So you're choosing 2 and you're adding to 1. I think there's a possibility of that. So this is going to return -1 from my code, but that should be wrong. Okay. So in this case, the only way this occurs is actually if you have 2 of the same value. So like 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. In order for the bits to kind of combine to one merged bit in the next bit value. So in this case, what is it going to do? So this would be something like 5 times 5 plus 4 times 4 plus 3 times 3 plus 2 times 2 plus 1 times 1. So let's say, where's the code here? So let's do the more general difficult case where bits, where sequence has duplicate values, bits will merge. So for the nums array 5, 4, 3, 2, 1, and say n is 2, so it's the sequence length, and the k is 1, this is the number of set bits. So the sequences here will be like 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So the product sums would be, product to sum would be 5 times 5, which is 25, 16, 9, 4, and 1, which is 20, 20, no, 20, 10, 30, 55. And there's no actual duplication of those sequences. They're all unique. Okay, 55. Okay, so what if it was something like m equals 3, k equals 1. So you need 2 of them to be duplicates, and then the other one should be 1 bigger in order to combine with the duplicate sum. So sequence would be like 0, 0, 1 or 1, 1, 2, 2, 2, 3, 3, 3, 4. Is there any other ones? I don't think so. So therefore the product sums would be 5 times 5 times 4 is going to give you 100. 4 times 4 times 3 gives you 16 times 3, which is 48. 3, 3, 2, 9, 2, 18. 2, 2, 1 is 4. So that's going to give you 48 plus 18, 66. Plus 4 is 170, so that's 170. And then how many ways to rearrange this? Guess number of ways to rearrange that would be 3. There's one unique, so you can do either like n factorial divided by the number of duplicate factorials, like 2 factorial, so it'd be 3 factorial over 2 factorial, or you can just say that like there's one kind of unique thing, so it's 3 ways to move that one unique thing. So this should be times 6. So that should be like 600 plus 420, so 1020. That's the wrong. Oh, whoops. It should be 3. 3 factorial over 2 factorial is 3. What am I doing? Yeah. So yeah, that's 5, 10. So what is this? What is the general pattern here? If you have, if k is 1 less than m, there should be exactly 1 duplicate. And that's not quite it. Oh my god, it's so complicated. So many possible things. So many possible things. I guess I probably need to come up with like the recursive way of handling this. So that's the main thing, right? It's just the recursion. It's like the get comp sum is just a simple recursive thing. And then okay, so what is the recursion going to be? So I need to tie it with either the get comp function, comp sum function, or with itself. Okay, so I'll say this is big F S R. I guess maybe I need to have a third parameter. S is the start index. Maybe V is the number of values and we're choosing R. No. Let's think about this. K is the number of total bits. So maybe you're choosing R places and you do B bits. This is where S is start index, R is number of values to choose, and B is the set bits. So how is that going to relate? So if R equals B, then return the other function, f of sk. So the smaller function f of s, I guess R and B is the same at that point. Else else I need to move towards the base case then, or the base case is that function. Oh, actually, I guess I should multiply. I'm not sure if this should be incorporated into this part times the factorial. Factorial of R? I'm not sure. Then if R is bigger than B, R is bigger than B, what does that mean? So if I'm choosing 2, I guess the other base case, if B is 0, then okay. B is 0, then I think that's the base case. So you're getting 0 bits. Wait, the base case here was if R is 0. If R is 0, return 1. I think that's still fine. And I think if S equals N or the remaining values is less than the number that you're trying to choose, then return 0. So it's not like an impossible thing. So those still remain as stopgaps here. If B equals 1 or if B equals 0, I guess this is actually just B, maybe? So B equals 0. B equals 0, then I maybe should be returning 1. B equals 0, I should be returning 1. Because if you're trying to get no bits to be on, then you're really choosing 0 at that point. There's one way to choose 0 things. Oh my god. So 001122 00. Okay, so no, I'm looking at the wrong thing. The sequence if it's 5, choose 1. Or if there's 5 things and you're trying to choose 2 of them to get 1 set bit, then this is one of those cases where it's pretty close to being a base case because you're left with just either choose 2 of the current thing or interesting. You're choosing 2 of the current thing or you're skipping over this one, right? Skipping over this usage of this bit or this value. So this is almost like a base case right here. It's almost like a base case. So you're not going to be able to lower the m by 1 and the k by 1. You have to lower the m by 2 and the k by 1. So you're almost getting to a base case in that case. Well, the next recursion would get you to a base case. Okay. So if the base case is when m and k are the same or m and b is the same, then so it's like f s. So you're choosing the current thing, choosing 2 of the current thing. I guess. So something like array at the current index times array at the current index times f s plus 1 you've done 2 things, added 2 things to the sequence, and you move 1 bit. Kinda like that. It's not quite like that. Oh my god, it's not quite like that. I almost want to say this should be s plus 2. The issue here is like if you, let's say you had nums equals 5, 4, 3, 2, 1, and m is 4, and k is 3. K is 3 or maybe k is 2. Like you can choose a sequence that is 0, 0, but then if on the next thing you choose a sequence that's 1, 1, this in theory This would combine to all be 1 bit, I think. No. How many bits is this combined to? Or let's say the sequence is 0, 0, 1. Actually, yeah, I'm just straight up confused. I think that there is some sort of deal where you choose the next thing in the sequence, it gives you less bit collapse than maybe you expect. Maybe I'm wrong. Maybe it always gives you a collapse, or the number of collapses that you expect. Take 0 times 0, and then you move to the next bit. You used up 2 of your things, and you've used up 1 of your set bits. Alternatively, you skip over this thing, so you do f of s plus 1, r minus 1, or rb. So then it should be 0, 0 plus 1, 1 plus 2, 2 plus 3, 3. I think maybe this should be, there's a missing factor. Is there a factorial here? Is there a factorial here? I don't know. F of s plus 1 rb, r minus 2, b minus 1. That seems right. 0, 0. So what does that mean here? So if it's m3, k is 1, then if you pick 0, 0, then at that point you get f of index 1, choose 1, and you want 0 bits. If you choose 1, you want 0 bits, then it's going to return 0 at that point. If you choose 1 and you want 0 bits, it's going to return no. Yeah, it's going to return one way of doing that. That's wrong. Because technically it should be returning like 1 at that point. Because then that 1 would combine with the previous addition to get you back to zip 1. Or what is this doing actually? Oh my god, what is this doing? don't even know. My eyes gloss over and refocus. All this looks like just absolutely impossible crap. Do 001 112 223 334. So choosing 3 values in a sequence. Choosing 3 values for your sequence that add up to 1 set bit. The only way that works is if you choose 2 duplicates. A duplicate value and then one bigger than that. Question is how you make that into recursive logic. So in theory, if you had something that was choose 4, k equals 1, and the sequence was arbitrarily long, let's say, say it's even 5. Choose 5. Let's just do 4. So m equals 4, k equals 1, because I think maybe there's multiple ways of actually handling this. So in theory, you could just cascade it. So like 0, 0 makes a 1 in the next bit. So then you choose 1, and that makes a 2 in the next bit. You choose 2. So it could be like that, or some starting with, instead of 0, 0, like 1, 1, 2, 3, or 2, 2, 3, 4, 3, 3, 4, 5. Alternatively, what? I think if you choose maybe 0, 0, 0, 0, oh, that's too many zeros, huh? Because 2 zeros make a 1. And then 2 ones make a, so that these 2 zeros make a 1. And then the 1, 1 makes a 2. And then 2, 2 makes a 3. But you never made it, you never added 3 here. But in theory, if this was like, if this was something where m equals 5, k equals 1, sequence could be 0, 0, 1, 2, 3. This makes a 1, this makes a 2, this makes a 3, that makes a single 4. That's set. Or it could be something that is 0, 0, 0, 0, 2. Because then these 2 zeros make a 1, these 2 zeros make a 1, those 2 ones make a 2, the 2's make a 3. So, how to handle that? Almost feels like a stack. Almost feels like a stack. Like you push 0 onto the stack, you push 0 on the stack. And then you pop into the 2 zeros on the stack and you push a 1. So the stack is 1, and then you push a 1 into the stack and you make it into a 2 on the stack. Push 2 on the stack, make that into a 3 on the stack. Push, so this, and the stack size is the number of bits, or the size of the stack is the number of bits that are on. So if you do, interesting. The stack size is number of bits that are on. So if you push 0, 0 into stack, pop, push 1, so 1 is on, push another 0, push another 0, so the stack is 1, 1, so that pops and push a 2. Interesting. Then the stack can be pretty weird. So if you do like push 2 zeros, get a 1, push another 2 zeros, get a 2, then you push 0 onto the stack, and then you move down, you push a 1 to the stack, and the stack becomes like 2, 0, 1. At that point you can't, and then if you push another 2 onto the stack, and the stack doesn't even recognize the previous 2. Eeks. This is way too hard. 0, 0. 0, push 0 onto the stack, push 0 on the stack, pop, push 1. At that point, do you push another 0? And then you have to do the fucking factorial thing. Oh my god. Yeah, fucking Advil. Where is... What they should really add onto CodeHS is a button that every user can do for every problem. I think it probably should be like right here. It should be a flag button, a white flag button, to indicate that the person has attempted and determined that they have raised the surrender flag after trying the problem. Is there an actual white flag button somewhere? Because that would be interesting to see, just as a social engagement activity indicator. How many people raise the white flag on any given problem? I think that would be more interesting than acceptance rate. The rate of people, or the number of people who just thought the problem was just too darn difficult. Or maybe a brain icon for people who got a headache from it. Oh my god. Alright, that's it for me. I'm gonna maybe ponder this overnight, maybe take a Advil. Bye.